Welcome to This Explainer. Look, if you're a technical leader, a plant manager, or a machining process engineer, you already know the relentless, high-stakes pressure of the shop floor. I mean, every single second of cycle time, every microscopic deviation in a cut, and every unexpected tool change, it all directly impacts your bottom line. And when margins are this tight, there's just zero room for inefficiency. So today, we're doing a deep dive, a highly structured ROI analysis on premium tooling upgrades. We're going to look specifically at how advanced geometric designs and extreme temperature materials can fundamentally transform your precision machining operations. Basically, we want to shift your tooling from a basic consumable expense right into a strategic, profit-generating asset. Okay, real quick, here is our agenda for today's analysis. We'll start with the direct comparison, move into the technical edge, build out the business case, and finally, evaluate your next steps. Let's get right into it. Section 1, the direct comparison, standard versus upgraded tooling. We're going to start by looking at those baseline pain points you face on the shop floor every single day. Let's contrast these two approaches. When we're talking about standard square end mills, honestly, you're looking at a massive engineering liability that's basically masquerading as a conventional tool. In precision machining, those sharp corners, they act as prime locations for severe stress concentration. All the force of the cut gets funneled into one microscopic point. That fundamentally leads to poor surface finishes and highly unpredictable rapid tool wear. But when you upgrade to specialized corner radius designs, you introduce this specific curvature at the cutting edge, and that completely changes the physics of the operation. The physical stress is distributed evenly instead of being concentrated in one weak point. This makes the upgraded tool totally optimized for complex contours and aggressive, heavy material removal. It's such a simple geometric shift, but it yields massive operational stability. And this perfectly illustrates the downstream consequences. Those stress concentrations at sharp corners, they aren't just some minor engineering footnote, right? They are the root cause of systemic inefficiencies. They inevitably lead to failing tight surface roughness specs. When you push your machines with standard square mills, that concentrated stress causes unacceptable, resonant chatter during complex contour machining. And what happens then? Well, to compensate for that chatter, your programmers are forced to artificially slow down the feed rates. So now you have excessively long cycle times. And worse, if that chatter persists, you literally end up with rejected parts. In heavy manufacturing, scrapped parts and wasted machine hours will absolutely destroy your profit margins. That brings us to Section 2, the technical edge, engineering the perfect cut. Let's dive into the engineering physics here and see how Evergreen's premium tools change the game. Here's our core definition for corner radius machining. It's the utilization of a specific geometric curvature at the tool's cutting edge. The crucial takeaway here is that corner radius machining isn't just an arbitrary shape. It's a highly calculated geometric strategy designed to minimize stress concentration. And by doing that, you completely eliminate chatter. For any process engineer listening, you know eliminating chatter is the absolute holy grail of milling. Without that vibration tearing up your workpiece or snapping your tool, your shop is suddenly empowered to push for significantly faster feed rates, completely without sacrificing the dimensional integrity or the finish of your final part. Now, what's genuinely fascinating here is the absolute precision of the engineering. When we examine Evergreen's cemented carbide corner radius inserts, we aren't talking about some general one-size-fits-all curve. Notice the exact R values, ranging precisely from 0.2 millimeters all the way up to 1.2 millimeters. This granular level of control is literally everything. By selecting the exact right radius, 0.2 for a tighter corner profile, or maybe 1.2 for maximum cutting strength, process engineers can perfectly dial in that stress distribution for their specific application, their machine rigidity, and their material. But what happens when the machining environment gets even more extreme? Well, Evergreen's PCBN, that's polycrystalline cubic boron nitride, cutters are the definitive answer. To put this into perspective, these cutters maintain incredibly high hardness and heat stability, all the way up to 1,300 degrees Celsius. Just think about that. That is roughly the temperature of flowing lava. At those thermal extremes, standard tooling basically melts or just instantly fractures. But PCBN, it thrives in it. This makes these tools the ultimate uncompromising choice for machining hardened steels up to HRC 60, tricky powder metallurgy components, and those extreme high-temperature aerospace alloys based in nickel, cobalt, chrome, or iron. Let's see how this incredible physics translates into real-world application data, because this proves the technical edge for sure. Check out the high-efficiency machining of hardened steel at a baseline of 150 meters per minute. I mean, that's respectable, right? But then notice the massive exponential jump to 1,200 meters per minute for high-efficiency finishing on gray cast iron. And that's paired with a robust feed rate of zero point 0.3 millimeters per revolution. That is a jaw-dropping increase in speed. When you have tools engineered to handle those aggressive cutting parameters without catastrophically failing, you completely rewrite your production timeline and absolutely shatter your previous output ceilings. All right, section 3, the business case, bridging physics to finance. We've seen the physics, but advanced geometry has to ultimately translate into shop floor profitability. I want to anchor on this specific number for a second, 1,300. That 1,300 degrees Celsius limit we just talked about for the PCBN cutters, it's not just an impressive technical spec sitting in a glossy catalog. It is the exact thermal threshold that guarantees extended tool longevity. Heat is the ultimate enemy of the cutting edge, period. So when your tools are engineered to actually survive extreme heat, unpredictable tool failure basically becomes a thing of the past. And consequently, your machine downtime plummets, keeping your spindles turning, and most importantly, your revenue flowing. Upgrading to these durable tools creates such a compelling, indisputable ROI for manufacturers. By eliminating those sharp corner vulnerabilities, you inherently lower your total cost per part. You completely eliminate part rejection due to chatter. You achieve pristine, ready-to-ship surface finishes on the very first pass. This directly boosts your overall shop throughput, all while maintaining strict, predictable tool longevity. Basically, you're doing significantly more work at a vastly higher quality standard without burning through your annual tooling budget halfway through the year. The compounding financial value across thousands of cycle runs, it's just massive. Finally, we reach section 4, evaluate your next steps. Let's talk about how you can actually implement this advantage right now. This quote from the source material perfectly summarizes the core value proposition of Evergreen's cemented carbide and PCBN solutions, the backbone of precision and durability for industrial applications. In heavy manufacturing, precision without durability is just a financial drain waiting to happen. You need tools that hold tolerance, yes, but they also have to survive the entire shift. Evergreen provides exactly that, uncompromising precision paired with relentless durability. So here's the logical next step for you. I highly encourage you to go straight to www.evergreencarbide.com, access the technical catalog, download the comprehensive technical datasheets, and really review the exact engineering specifications for the corner radius and PCBN tools we've been looking at. And honestly, don't just take the data at face value. Order a premium sample evaluation kit and securely test these aggressive feeds and speeds on your own shop floor. The proof will be in the chips you make. To wrap up this explainer, I want you to look closely at your current operations and ask yourself a really hard question. Are your current cycle times silently eating away your profit margins, or are you ready to engineer the perfect cut? Your facility truly cannot afford to keep losing ground to outdated sharp corner tooling in today's highly competitive industrial landscape. The upgrade is there, the physics are proven, and the ROI is exceptionally clear. Thanks for joining me for this analysis, and I really encourage you to take that critical next step toward high-efficiency machining today.